Have you ever wanted to preserve your kid's drawing like this? Or this? Or your sketches like these? In a more creative and tangible way, instead of just framing it and hanging it on the wall, what if you can turn it into real 3D object like these? Well, you can. My name's Alex. In this video, I'm going to show you how you can turn 2D sketches or drawing into 3D object. Please stay tuned and let's get into it. The concept is not new. It was first proposed over 20 years ago by Dr. Igarashi in his groundbreaking paper titled Teddy, a sketching interface for 3D freeform design. He introduced an ingenious way to create 3D models from hand-drawn sketches using just a few simple strokes. When I first came across this method several years ago, I was blown away. So much so that I decided to implement my own version. So I wrote code in Matlab programming language and I shared it on GitHub. In this video, I'll show you how to use my software, which only has 3 simple clicks that will be able to turn your 2D sketches into 3D objects like these. Let's get started. So in this video, it will contain 5 sections. I'll talk about the theory of the algorithm. I'll also talk about how to download and run the software. Then third, I'll talk about how to use the software. And then I'll have some discussion talking about some related work and today's newest technology. And then finally, I'll just showcase some of the results that I printed out. So let's get to it. If you are not interested in the theory, feel free to jump to the downloading and the running the software section. All right, theory of the algorithm. Let me explain the theory of how this algorithm kind of inflate the closed contour into a 3D object like this. Conceptually, it first triangulate the closed contour, which lead to a bunch of triangles. And then from those, it kind of constructs the skeleton, or in this paper, it's called chordal axes from those triangles. And then it modified the triangulation to construct some kind of fan-like structure. And then this leads to kind of the spine of the shape, and then the final triangulation. Finally, the algorithm elevates the spine based on some height that's proportional to the distance from the contour. All right, here I'm showing you how to download and run the software. First of all, hit the GitHub repo called Teddy Matlab. If you are experienced GitHub user, you already know how to git clone a repo. But if you're not, that's okay. Simply click on this code and then download zip. Takes a while to download because this repo is pretty large that I include a lot of samples like 3D models. All right, so now that's done. Let's move it to somewhere that you like. For example, I put it on my desktop and let's unzip it. This folder called Teddy Matlab Master. Click into it. In there, what you need to do is to click into Teddy. There's a Teddy Matlab for distribution, and double click on this my app installer web. Once you double click on it, it will ask you whether you want to run this. You will need administrator's privilege to run this guy. Just click on yes, and then it will try to download Matlab runtime from the web. So don't worry about this. This is all official stuff. There's no virus whatsoever. You can choose whatever folder that you want to. I'll choose desktop. I want to install it. Select next. Next it will download and install Matlab runtime. So click on yes, next, and the install. There's 496 megabytes, so it will take quite a long time. So just be patient with it. All right, now the Matlab runtime installation is done. Click on finish. And you will notice that it generates a couple more folders. So click on application where within the folder you will see several files. Double click on teddy matlab.exe. Sometimes it can be quite slow. Just be patient with it. Alright, now finally it's running. So if you have Matlab installed on your computer, then you can simply double click on this teddyapp.ml app, and then it will directly run this application for you. So basically that's how you can download, install, and run the app. In the next chapter, I'll talk about the usage of this particular app. There are several functionality you should know. Alright, let's get to it. Alright, so here let's talk about how to use this software. First, under the application folder, double click on teddymatlab.exe. So alright, so this software, it contains 3 main steps. First step being the sketch, second, generate the 3D model, and the third step is exporting the resulting 3D model. First, playing sketch, by clicking start sketch, just wait after the cursor turned into a crosshair before you draw. So once it becomes crosshair, you can left click the mouse button and then drag it to trace the outline that you want to draw. For example, I'm drawing a human shape thing here, right? And then once you're pretty close to your contour, just release. Once you release the cursor, it will automatically connect the last point to the initial point. Alright? So there are some constraints of this method. First, it has to be a single contour. In other words, you cannot draw 2 contours. Second, the shape that you draw is topologically equivalent to a sphere. Put it in simple words, it has to be a single closed shape. So in other words, you cannot draw like a donut and expect it to generate a donut for you. And the program simply wouldn't allow you to do so. So let me try again. Draw something like this, right? Then release it. And once you release the notice, you can then kind of drag, and it also generates some control point or is so-called waypoint. So for example, if I'm not happy with the position of this shape, I can place the cursor near a waypoint and wait until it becomes a circle shape. Then you can left click it, right? And then change its shape. Furthermore, you can also place your cursor near the boundary and wait before all the waypoint change its color. Then you can, for example, right click and then add another waypoint, right? So this is the power of Matlab. And you may wonder why I used Matlab at the first place. This is because this has so many functionalities. But basically how you draw a 2D sketch. Once it's done, the generate 3D model button will then show up. Then you can click on it, and then within a second, it will generate this 3D model. And you will notice the cursor now becomes a circular arrow shape. Once it turns into that shape, you can then left click the image and then rotate it, right? Furthermore, if you are not happy about the thickness of this model, you can change the thickness, and then it will reflect on the fly. If I want to be thinner, then boom, there you go, become thinner, right? So let's talk about the second mode of the sketch, which is overlay mode. So what it allows you to do is that sometimes you want to load an image, for example, your kid's drawing, and then kind of trace out the outline, right? So it allows you to do that. So I'm loading a image. For example, I want to load this guy. And then I can click on Start Sketch. Again, wait until the cursor becomes a crosshair before you start drawing. Right? So now I'm done with it. And just click on Generate 3D Model, exporting to a STL file for 3D print. And then you can click on Export STL to any place that you like. Now, the third sketch mode is called Load Binary Image. So what it means is that it will load some pre-processed 2D image and then generate 3D model. Here I have tons of a pre-processed binary, which I call binary image because it's just black and white image with the content filled with black ink. So for example, I'm loading this guy. Once I open it, and then just simply click on generate 3D model. Then boom, there you go, right? So this is basically the 3D model it generates. By the way, the third method, loading the binary image, is actually my favorite method because this way I can take my time using a image editing software to carefully trace out the boundary, correct my error, and it usually gives me a pretty satisfying result. So these are the 3 modes to do the sketch. Let me show you now how to pre-process an image to generate the binary image. Alright, so here I'm going to show you how you pre-process an image to generate the binary image. So to start with, use any kind of image editing software, for example, Photoshop. So for example, I opened up a sketch that my son drew when he was 3 years old, I guess, and then say I want to generate a binary image for one of the creature. Let's focus on this creature. So this is the image that I want to process. So what I can do is that I want to trace out the boundary. Instead of manually tracing it, I can use some tool, right? By kind of using the magic wand to select the outer region of it, right? And grow the outer region. So once I select the outer region, I can then add a layer, new layer. And I want to select the background with, I want to fill the background with white. Click on OK, and then I can fill the interior by right click, select invert, meaning I'm selected the interior of this shape, and then fill it with black. So there's a bucket tool, boom, and then there you go. And this is the binary image. Now pay close attention. There are some like noises when the program tries to find the contour. There are more than one contour in this image. There's the main dinosaur. There's also like for the contour for these small like noises. But my program is smart enough that it's going to choose the largest contour within the image. So let's then save this image. By the way, you can save it in the format of a JPEG or PNG, doesn't matter. The program should be able to load it just fine. And then click on load binary image. Go to where you save it. And then there's the binary image, right? And then click on generate 3D model. And then boom, there you go. So basically that's how you use this application. Just one thing I'd like to mention, there's a minor bug or feature of this app that I wrote. In the paper, the resulting 3D model should be smooth. However, I think due to some bug, or I call it a feature, actually, it generates this kind of non-smooth surface, right? If you look at this guy, here, it generates some kind of non-smooth surface. However, it adds this kind of artistic flavor, almost like you're sculpting sculpture. It's a beautiful mistake I made. Let me know what you think in the comment. I really want to know your thinking. Surprisingly good feature. I love it. There's also another thing I would like to mention. Now, observe how the resulting 3D model doesn't really look like a scorpion because the bottom part of the scorpion should be rather flat, right? Since the resulting model is symmetric along the positive and the negative z-axes, so what you can do is simply make a cut along the xy plane or z equal to 0 plane using other software. For example, I'm using Fusion 360. I think there's also other software that can do this. For example, Mesh Mixer. I used to do that. And then click on Mesh Cut Plane, select the object, right? And then select plane, observe, you want to choose this XY plane, and then choose trim, basically by ignoring the other part, right? Want to trim it, and at the bottom you want to fill with, for example, uniform or minimum. I choose minimum, and hit OK, and then boom, there you go. This is the resulting 3D model that you can send to 3D printer for print, right? If you're using like FDM print, then you know how beneficial it is to have like a flat bottom. You don't need any kind of support. We pretty much guarantee 100% successful rate for printing, right? If you are using resin 3D printer, there's also a technique, I think it's called flexible kind of plate. The resulting flat bottom of model is really kind of realistic, right? This video won't be complete without visiting Dr. Igarashi's webpage. So this is his webpage. You can download his application, which is written in Java. So you can draw a closed shape like so, right? Which generate a smooth surface. And then you have the ability, for example, to make a cut like that. Boom, this is so magical, right? And then you have the ability to even kind of extrude some part of the shape, for example, by drawing that, and then boom. And then there you go. This is pretty magical. It's amazing work, right? So I highly encourage you to visit his website and then try it out yourself. Alright, the second related word I want to mention is called Monster Mesh. So it also has the very basic functionality that is namely draw, contour. Not only that, it allows you to draw multiple contour, right, like that, and then inflate, and then boom, generate that, right? And mainly focus on bringing it to another level that is able to animate stuff, which I didn't spend a lot of time, but make sure to check out their paper and demo app, which is super amazing. By the way, their method to inflate a closed contour is different from Dr. Igarashi's method. They are solving a constrained Poisson equation, which in the future I plan to implement, which is very elegant. Lastly, I want to mention the work of AI. Nowadays, AI is a very powerful tool that does amazing things. So if you just Google converting 2D drawing to 3D and with the keyword AI, a few work that does this job. For example, I just arbitrarily tried pick a website that does this and then upload the same image, this guy, using my software, and it is doing quite amazing job, right? Like this guy. And also, I also tried the lizard image. What it does is that it is able to figure out like the shape of the 3D model, even beyond my software can do. It's quite amazing. Here are some of the 3D printout results. By the way, if you follow the video this far, that means you are also very interested in this kind of topic. I would really appreciate if you can support me by being my Patreon. I'll put a link under the description, like buy me a coffee. I'm using my free time to create video like this. I'm hoping this can provide some helpful information for you. So your support is very important to me. If you enjoyed this video, please like and subscribe to my channel. I would really appreciate your support. I'll see you in the next one.